Mile marker 3, absolute value inequalities. Recall, absolute value is a distance from zero. Keyword being distance. Now distance is not negative. Here are some rules. The absolute value of x is less than a means negative a is less than x is less than a. Here's the other rule. Absolute value of x is greater than a really means x is less than negative a or x is greater than a. Let's take a closer look at this. The absolute value of x less than a means negative a is less than x is less than a. Let's say you are dog walking, so you use a leash that is 5 feet long. That means you have a limit of how long the leash is, which is 5 feet. So imagine you are walking your dog. Now we all know dogs don't stay right beside you. They like to go in front of you, and sometimes they even run behind you. But the goal is the leash is going to keep the dog safe. In other words, the dog has to stay between 5 feet in either direction, either in front or behind. Which means negative 5 is less than x, which is less than 5. The dog has to stay between negative 5 and positive 5. So the solution in interval notation would be negative 5, 5 with parentheses. As a helpful hint, the less than symbol could be a reminder of the word leash. Less than, leash. The other rule states absolute value of x is greater than a means x is less than negative a or x is greater than a. Say there is a grass fire and everyone must stay 4 blocks away for safety. So we got to keep a distance away from something. So let's say we have a grass fire and we need to stay away 4 blocks. Well, we can stay on one side of the fire or on the other side of the fire. But we cannot be in the middle of where the fire is for our own safety. So people must stay away a limit of 4 blocks either direction. We can be x is less than negative 4, which means further to the left of the fire, or x is greater than 4, which means we're further to the right of 4. The solution in interval notation would be negative infinity to negative 4, parenthesis, union, which is that u, that means or, parenthesis 4 to infinity. We would be safe in any of those places, just not in the middle. And as a helpful hint, if you look at the greater symbol, greater could mean great or, as a reminder that it will be an or statement. Example 1. Solve, graph, then write in interval notation. And so for A, we have the absolute value of x plus 2 is greater than 4. Here's our steps. First, we want to make sure that the absolute value is isolated. So we check, and it is. Next, we want to check to see if it's compared to a positive value. 4 appears to be positive, so we're good. Now we need to determine if this is a leash or fire. So look at the inequality symbol right now. And notice greater means great or, which means it's the fire scenario. So now that we know what scenario it is, it's time to set it up. So the situation will be x plus 2 is less than negative 4, which means I'm past 4 units to the left, or x plus 2 is greater than 4, which means I'm further 4 units to the right. Now that I have them set up, it's time to solve. Looking at the left inequality, to isolate x, we need to subtract 2 on both sides. The 2's will cancel, giving you x is less than -6. Or, now it's time to solve the other inequality. Again, to isolate x, we need to subtract 2 on both sides. The 2's cancel, and we find that x is greater than 2. And that would be your solution. Now that we have the solution, we must graph. And looking at our solutions, we have -6. And because it says x is less than -6, it means we want smaller values than -6. So we shade to the left of -6. Now at -6, we must decide, is it going to be a bracket or a parenthesis? And because it does not have an equal to, it will be a parenthesis. Next, we find x is greater than 2, so we find 2 on the number line, and because it's greater, we want the values that are larger, so we shade to the right of 2. And again, because there is no equal to, it will be a parenthesis. And there is your graph. From here, we're ready for interval notation. And that would be -infinity to -6 parentheses, union, which means or, parentheses 2 to infinity. Example 1b. Absolute value of 2x minus 5 plus 2 less than or equal to 9. Here's our steps. First, isolate the absolute value. So let's check. Here's the absolute value, but it's not by itself. So we need to subtract 2 on both sides, which leaves us with absolute value of 2x minus 5 is less than or equal to 7. Now we've done the first step. From here, we need to now compare it to see if it's compared to a positive number. Look at 7, and it is a positive number. Now we need to decide, is this a leash or a fire scenario? So check out the inequality. Because it is a less than, that means it is going to be a leash, which means I am stuck between two specific values. And so, -7 is less than or equal to 2x minus 5, which is less than or equal to 7. So I'm stuck between a positive 7 and a -7. This is known as a compound inequality. When you have two inequality symbols, you're still going to have multiple parts to it. We normally put a line at an equal sign, but this time we're going to draw lines at the inequality signs. We no longer have a left and a right side. We now have a left, a middle, and a right. But the rules are still the same. What you do to one side, you must do to all three sides. So again, our focus is on the variable x, which is in the middle, and your first step is to add 5 to all three sides. So on the left, that becomes a -2. In the middle, the 5's cancel, leaving you with 2x. And on the right side, 7 plus 5 is 12. Now again, focus on the middle. We want to get x by itself, so we must divide all three sides by 2 so we can get x alone, which gives us -1 is less than or equal to x, less than equal to 6. Now that x is isolated, you have your solution. X has to be somewhere between -1 and 6. So we're ready to graph. Because imagine the dog walking, we must stay between -1 and 6. From here, we must decide brackets or parentheses. The inequalities, because they have the equal to, they must be brackets. From the graph, we're now ready for interval notation. Bracket, -1, comma, 6, bracket. Example C, absolute value of 7x plus 3 less than or equal to negative 8. So check to isolate the absolute value. Looks good. Check to compare to a positive value, and we look, is that positive? No, it's not. So we need to investigate. There's two scenarios. That symbol involves a less than or an equal to. So we need to kind of talk and discuss. Absolute value, remember, means distance. So we have the distance compared to a negative number, and distance cannot be less than a negative. Remember, distance is positive or nothing, but it cannot be less than a negative. So that's false. Distance cannot equal a negative number also. So that is false. So since those are both false statements, the answer is no solution. And so, if you were asked to graph this, it would be a blank graph with no shading. Example D. Absolute value of 4x plus 11 greater than negative 2. Isolate the absolute value. Looks good. Compare the number. Is that positive? No, it's not. So again, let's investigate. That symbol says greater than, so let's check. Absolute value means distance. Can distance be greater than a negative number? And it can. Distance is greater than a negative number. So since that is always true, your answer is all real numbers. No matter what you put into the absolute value, the result will always be greater than that negative 2. So on the graph, it would be a completely all shaded graph, all the way from the left to the right. For interval notation, it would be negative infinity to positive infinity. Example E. The absolute value of 2x plus 1 is less than or equal to 0. First, we want to make sure the absolute value is isolated, and it looks good. Next, we need to check to see if it's compared to a positive number, and 0 is not positive. So we need to investigate. Looking at the inequalities symbol, it is two scenarios. That is a less than, and it involves an equal to. Now remember, absolute value is a distance. Can distance be less than 0? No. Can distance be equal to 0? Yes, distance can be 0. So we are going to focus on that. If distance equals 0, it means we have 2x plus 1 equals 0. And so to solve for x, our first step would be to subtract 1 on both sides, which gives us 2x equals negative 1. To undo multiplying by 2, we need to divide both sides by 2, which gives you x equals negative 1/2. That is your one and only solution. To graph this, what makes this one different is it's not a range of numbers, it's only one solution, and that solution is at negative 1/2. So on the number line, plot a single point. Now that we have the graph, we need to do interval notation. Again, because we do not have a range of values, we are not going to use brackets and parentheses. Instead, we're going to use braces. And your one and only answer would be brace negative 1/2 close brace.